Here's a video containing the solution for number 4 from the 2010 AB Calculus BC. So this is section 2, part B. Yeah, I was just looking for this if this is form B or not, but I think it's not form B. It's just form A. The last one that I did was a form B. That's why I'm thinking that. All right. So let's get started. Here's a region R. It's bound by this line y equals 6, and also by this graph of y equals 2 times the square root of x. And notice this is a no calculator problem. It's not super common, but hey, we can handle that, right? These do show up sometimes as no calculator problems. So let's find the area of that region. The area of a region is just the integral of the top one minus the bottom one. So the top one is just the line 6, and the bottom one is 2x to the 1/2 dx, and I'm going from 0 to 6. Right? That should all look good. And there's another way to do this. I'm just realizing that might be easier. I'll show you that in a second. So let's finish this and see how it goes. So the antiderivative of this is, that would be 6x, and then bump the exponent up 1 to 3/2, and divide by the new exponent. So the same as multiplying by 2/3, would be 4/3, from 0 to 6. Right? Oh, why am I going from 0 to 6? Whoops. Hey, that's going to be a little bit better. The x value is 9, not 6. So that's going to be better here for taking square roots. So let's see if we can... Oh, you can't see what I'm doing. Sorry. There it is. Sorry about that. And plugging the 9 in. When we plug the 0 in, we get 0, so that's great. So we just have to plug the 9 in. I get 6 times 9 minus 4/3 times 9 to the 3/2. That means the square root of 9, which is 3, cubed, which is 27. And that's 54 minus 1/3 of 27 is 9, times 4 is 36, which is 18. You could put square units if you want, but they didn't give any units here, so that's not really necessary. So that's 18. The other way you could do it is if you think about this way, right? If you think about the inverse of this, you could also do it as a dy problem. You could say, hey, if I solve this, that would be the same as if I square both sides. That's like x equals 1/4 y squared. Right? Are you with me there? Square both sides, that'd be y squared equals 2x. Y squared equals 4x, and then you divide over. And then if you look at it that way, you could do the integral from y value to y value. That would be 0 to 6 under this 1/4 y squared dy, and there's no subtraction to do. It's just the one region, right? Because it goes all the way up to the y-axis. So just real quickly, if you thought to try it that way, let's see if we get the same answer. So that's 1/4. The antiderivative of this is y cubed over 3. I'm going to move the over 3 part out. That'll make that 1/12. Y cubed from 0 to 6. And 6 cubed is, let's see, the 0 just makes it a 0. That's 6 times 6 times 6. One of those makes that a 2, and that 2 cancels with that and makes it a 3. 3 times 6 is 18, so you get the same thing. So either way, you should get 18. All right, let's try part B. Write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 7. All right, the horizontal line y equals 7 is up here. So when I rotate around that, that means this is going to be the outside radius and this is going to be the inside radius. So that's going to look like volume equals pi times the integral from 0 to 9 of the outside radius, which is 2 square root x, minus the 7, right, because that's the shift. We're not rotating around the x-axis. If there's any shift, you got to put that in, minus the inside radius, which is y equals 6 minus 7. Of course, the inside radius is just 1. So 6 minus 7 is negative 1, but when you square it, it's just like 1 squared. You can leave it as 1 squared, or you can write a 1 there, whatever you want. But that is the integral. We could actually solve that, but it looks like it would get a little bit messy. All right, part C. The region is the base of a solid. For each y between 0 and 6, the cross-section of the solid taken perpendicular to the y-axis, is a rectangle whose height is 3 times the length of its base in the region R. And they want us to write, but do not evaluate the integral for that. So now we're slicing across this way, and each one of these is the base of a rectangle that's 3 times as high as it is wide. Well, these now, I need this in x equals form because we're slicing across this way. That makes it a dy problem, but I already did that. So this right here, that's x, right? X equals, and that's this. So stop and think about that for a second, right? Now that we're slicing this way, it's a dy problem. And it's 3 times as high, so that would be 3/4 y squared. So what's the area of this rectangle? The area of this rectangle is 3/16 y to the 4th. And once you have an expression for area, you just have to integrate it. So volume equals, no pi here because they're rectangles, 0 to 6 now, not 0 to 9, because I'm doing 0 to 6, right? We're doing y values of the area, which is 3/16 y to the 4th dy. And that's it. That would give you the volume of that solid. Not bad. Under 8 minutes again.